Hi, this is Lucas Pylypczak here to present the final project that Madhur Murli and I worked on for MMI 504 software synthesizer design. For this project, we were asked basically to add some version of an arpeggiator or step sequencer to our synth, along with anything else really that we wanted to implement. So before going into the ARP, I wanted to go quickly over the sample and hold oscillator that we designed and chose to add to our synth for this final project. And for this oscillator, the way that it works is you have oscillator 1 and oscillator 2 as sources that are fed to the sample and hold mixer in some amount each. And that mixed waveform is then sampled at a new rate defined by SH rate here. So looking at this green waveform here, if that's what's coming from the sample and hold mixer, that waveform is sampled and the orange dots represent those points at which it's sampled. And the orange waveform here to the right is what the resulting waveform would look like, where each of those points is held for the duration of the sampling interval. That new waveform can then be used as a source to modulate the pitch of the oscillators, the filter cutoff frequency, or the output amplitude of the synth itself. So to demo that really quickly, I have a really simple patch first, and I'm going to go and just show each of those modulations working and how they sound individually. So here is the mix being set up, and then the pitch modulation being increased. So you can hear as it's increased, the pitch of the oscillators changes depending on where those sampling intervals are lining up with it. Next is the filter cutoff, which with a higher Q is a lot easier to hear. And again, depending on the rate, you get either kind of smoother sliding up with the waveform or kind of more random sounding changes. And then finally, the amplitude modulation. So this can be useful if you want swells that aren't exactly in time and have some kind of pulsing beat to them. You can make some cool effects if you mess around with it and get some things to line up nicely with that. And now next is going to be the more musical sounding patch that I said I was going to load up. So here is how that sounds using all of that together. So right now you have both pitch modulation and the filter cutoff modulation both working. And if I pull down the pitch modulation and the cutoff, you can hear it clean up to what it sounds like. Putting the filter cutoff modulation back in and changing the Q, which will change basically how high that modulation goes on the filter cutoff as well. So using this to kind of get shimmery effects or to give your patches a bit more movement. So that basically sums up the sample and hold mixer, and the next thing that we implemented was that ARP or step sequencer, and for this we chose to kind of go a more non-traditional route in implementing it, being inspired by the combinatorial music theory paper that Will showed us in class. We came up with the idea of giving the user the ability to implement some of those operations discussed in the paper on patterns and pitch sets to come up with some new musical ideas and to see how those patterns would relate and change then. So the first one is the inversion operator, which could be thought of as a reflection around the vertical axis for the pitches selected. So for example, if you have the notes here C, E, and G, which create a C major triad, inverting that would create the notes C, F, and A flat, creating an F minor triad. And to demo that really quickly, here is first going to be a C major triad. Then when inverted, comes an F minor triad, back to C major. So another interesting example is using a major scale, which when inverted almost becomes a minor scale descending, except that you have a lowered second scale degree. so it's like a D flat instead of a D natural. But with kind of any of these sets that you choose, it's interesting just to mess around and come up with some new lines and patterns based off what you had selected. And kind of going off that, it was interesting to realize that you could then use this arpeggiator also to do descending lines. And so taking something that sounds normally not so good musically here, and then inverting it, gives you the kind of famous lament bass line pattern. So it was really cool with that one, kind of just to see how those patterns sound when they are inverted into their original states and then back into something that we know or are more familiar with. So the next operation that we implemented was multiplication, which is done by taking the scale degrees and multiplying them by some factor and then mod 12ing that result. And one of the pretty fascinating instances that's discussed in the paper is when you take the first 5 pitches and apply a multiplication by 5, the resulting set is a species of pentatonic scale. So to quickly demo that, I'm going to start with like this. First, with that multiplication by 5 on, just want to really quickly set up the notes. Okay. So then, if I invert it, you'll also get a different species of pentatonic scale. And then the interesting thing is that any kind of 5 consecutive notes or selected pitches will also give you these patterns. So shutting it off now, you can hear that just the chromatic steps, and then when you go back to the multiplication, it sounds more like a pentatonic scale. And with using factors like 5 and 7, you get all unique values for your pitch values. So you can kind of mess around with just random sets then within that to do what you want. With different multiplication factors, you'll have more repeated pitch values. So some are more useful than others, but still you can come up with some cool patterns with that. So the final operation that we implemented was the transposition operation, which can be thought of as rotating the pitch set around the circle. And when implementing this, we wanted the user to have an easy way to control this operation. And being inspired by the discussion of laying these patterns out on a fingerboard, we came up with the idea of using the XY pad as the control surface. So for each increase in the y-axis position, that corresponds to a transposition of 5 semitones or a perfect fifth. And for the x-axis, we decided to implement 2 modes, one being transpose root on, the other one being transpose root off. With transpose root on, the selected pattern is transposed by 1 semitone with each increase in the x-axis position, and with transpose root off, only the notes in the pattern that are above your position on the x-axis will sound. So it gives the user the ability to play kind of within that selected pattern. So first here is the transpose root on. So as I slide up, it just transposes the entire pattern up. And back down, going up. You can really do some kind of 1, 4, 1, 5 patterns. Super easy using this. next, I'm going to just load up a blues scale and then shut the transpose root off and then show how that works. So moving within the pattern now. You can really just kind of move around throughout the pattern and up and down the fingerboard. And the better you get at controlling and knowing where you're at, you can get some cooler things to come out if you become a better player at this than I currently am at the time. So here is then now just a major scale, kind of doing the same thing. So that is the transposition operator. And the last couple things that I'm just going to go through are kind of combining all those operations and just doing more performance kind of based stuff. So this is going to be using both the transposing the root and the inversion. And this is one of those times that I wish I had kind of two hands to control this so that I can do two at once, but I'm stuck holding the notes as well. So the next example does the kind of same inversion as well as transposition on the y-axis. And then forgive me if I don't hit this one coming up here. Oh, there we go. Yeah, so the more you practice and kind of know where those key positions are, or if there's a grid laid out on top of it to make it easier to see, definitely becomes a lot easier to play and make it more of a kind of like a performance aspect. So that's basically it for this video. Let me know if you have any questions, and thanks for watching.